Let's examine an interesting type of quadratic equation that has a special structure. Here we have the equation x squared minus 9x squared equals 0. Take a moment to observe what makes this equation different. Notice that both terms in this equation contain x squared. This is unusual compared to typical quadratic equations where we'd normally have different powers of x. The standard form of a quadratic equation is a x squared plus bx plus c equals 0, where we have different powers of the variable x. Our equation doesn't follow this pattern. When both terms contain the same power of x, in this case x squared, we can use a different approach called factoring out the common variable. This technique allows us to simplify the equation significantly. To solve this equation, we'll factor out the common term x squared, which will transform our equation into a much simpler form that we can easily solve for the values of x that make the equation true. This type of problem demonstrates an important algebra skill, recognizing common factors and using them to simplify equations. Let's move on to see how we can apply this approach. Let's solve this quadratic equation by looking at the terms. We have x squared minus 9x squared equals 0. Notice we have the same variable with the same exponent on both terms, which means we can combine them. Remember that when we don't see a coefficient in front of a variable, there's an implied coefficient of 1. So the first term is actually 1 times x squared. Let's write this out to make our work clearer. Since both terms have the same variable x squared, we can factor out x squared and group the coefficients together. This is similar to how we would combine like terms in an expression. We get 1 minus 9 in parentheses multiplied by x squared equals 0. Now we can simplify the expression inside the parentheses. 1 minus 9 equals negative 8. So our equation becomes negative 8 times x squared equals 0. So we've successfully combined like terms in our original equation. The simplified form, negative 8x squared equals 0, is much cleaner. In algebra, this kind of simplification is an important first step before solving for the variable. To find the value of x, we would divide both sides by negative 8x, giving us x equals 0 as our only solution, since any number multiplied by 0 gives 0. Here we have the equation negative 8x squared equals 0. To solve this equation, we need to isolate x squared on one side. We can divide both sides of the equation by negative 8, which I've highlighted in red. This is a key algebraic technique. Dividing both sides by the same value maintains the equation's equality. When we divide negative 8x squared by negative 8 on the left side, the negative 8's cancel out, leaving us with just x squared. And on the right side, 0 divided by any non-zero number, including negative 8, always equals 0. This is because 0 contains no quantity to distribute. It's crucial to remember that we can only divide by non-zero constants. Fortunately, negative 8 is not 0, so our division is valid and preserves all the original solutions of the equation. So our simplified equation is x squared equals 0. This clean form makes it much easier to determine what value of x will make this equation true. This algebraic technique of dividing both sides by a coefficient is essential when solving equations. We've transformed negative 8x squared equals 0 into the simpler form x squared equals 0, keeping the same solution throughout the process. In our previous work, we simplified our quadratic equation to x squared equals 0. Let's now solve for the value of x. To isolate x, we need to take the square root of both sides of the equation. This is a standard technique for equations where the variable is squared. Applying the square root to both sides gives us the square root of x squared equals the square root of 0. Remember that when we take the square root of both sides, we're performing the inverse operation of squaring. The square root of x squared simplifies to the absolute value of x. This is because the square root of a squared term always gives the positive value, regardless of whether x is positive or negative. Since the absolute value of x equals 0, we can deduce that x must equal 0. This is because 0 is the only number whose absolute value is 0. No other value, positive or negative, would give an absolute value of 0. This solution, x equals 0, is actually what we call a double root of the quadratic equation. To understand this concept, let's look at the original equation in factored form. In general, a quadratic equation can be written as a product of two factors set equal to 0. Notice that the factor x minus 0, or simply x, appears twice in our factored equation. When the same root appears multiple times in a polynomial equation, we call it a multiple root. In this case, x equals 0 is a double root because it appears twice. When we multiply these two identical factors together, we get x squared equals 0, which is our original equation. This confirms that x equals 0 is indeed a double root of the original quadratic. To summarize, we found that the solution to our quadratic equation x squared equals 0 is x equals 0. Furthermore, this solution is a double root, which means it satisfies the equation twice and appears as a repeated factor in the factored form of our equation. Let's solve the quadratic equation x squared minus 9x squared equals 0 and compare it with a standard quadratic equation. Looking at our equation, we need to combine like terms. Notice we have x squared minus 9x squared, which means we're combining two terms with the same variable and exponent. After combining like terms, we get negative 8x squared equals 0. To isolate the x squared term, we can divide both sides by negative 8. This gives us a cleaner equation to work with. Now we have x squared equals 0. If a square of a number is 0, then the number itself must be 0. This is because 0 times 0 equals 0, and no other number squared gives 0. For comparison, let's look at a standard quadratic equation. X squared plus 5x plus 6 equals 0. Unlike our original equation, this has all three terms of a typical quadratic: an x squared term, an x term, and a constant term. To solve this standard quadratic, we'll factor it into two binomials. We need to find two numbers that multiply to give 6 and add up to give 5. Those numbers are 2 and 3. When we have a product equal to 0, at least one of the factors must be 0. So either x plus 2 equals 0 or x plus 3 equals 0. Solving these equations gives us two different solutions. To make the comparison clearer, let's move our original equation to the left side of the screen and the standard quadratic to the right side. Now let's explore why our original equation has only one solution while the standard quadratic has two. This involves understanding the concept of multiplicity, or what we call a double root. Let's re-examine our original equation and think about it in terms of its factored form. First, we combine like terms. Both terms involve x squared, so we get negative 8x squared equals 0. We can rewrite this as negative 8 multiplied by x equals 0. This exposes the structure of our equation more clearly, showing that x appears as a factor twice. When we solve for x, we get 0 as our answer. But notice that in our factored form, x appears twice. This means that x equals 0 is a solution with multiplicity 2, or what we call a double root. A visual way to understand the difference between our equation and the standard quadratic is to plot their solutions on a number line. For our original equation, x squared minus 9x squared equals 0, we have a single solution at x equals 0. However, this solution has a multiplicity of 2, meaning it appears twice in the factored form, making it a double root. In contrast, the standard quadratic equation x squared plus 5x plus 6 equals 0 has two completely different solutions: x equals negative 3 and x equals negative 2. Each of these roots appears only once in the factored form, making them distinct roots. The key difference lies in the structure of the equations. In our equation, the factorization leads to the same solution appearing twice, which is mathematically different from having two separate solutions. This double occurrence creates what we call a double root. When graphing quadratics, a double root corresponds to a point where the parabola touches the x-axis but doesn't cross through it. It just kisses the axis at that point and then continues in the same direction. Distinct roots, on the other hand, represent points where the parabola actually crosses the x-axis. Understanding double roots versus distinct roots helps us analyze the behavior of quadratic functions. Our equation x squared minus 9x squared equals 0 simplifies to negative 8x squared equals 0, giving us a double root at x equals 0, while standard quadratics typically have two distinct roots.